Hello everyone and welcome back. Excuse me, I left my microphone too amplified. Um, so this one will be just about monitoring delta V, the basic steps to do that. So, of course you've got your computer, but you also have this box here called the entry monitoring system. One of its most basic, but most used mechanisms is monitoring delta V. So it's got an accelerometer in it that's able to monitor in a forwards and backwards direction. When you burn forwards, the delta V will count down, it'll go negative. When you burn backwards, the delta V will count up and will go positive. One of its other functions is if you set it sort of ahead, like that, and you start, burning forwards, it counts down to 0, and it's able to cut off the engine then at that point. So a pretty nifty function, but we will only be talking about just monitoring, just the bare basics, and it's one of the first things you'll do on every Apollo flight. Whether it be TLI, a little undocking maneuver, anything. Pretty much every Apollo mission starts with some monitoring via Program 47, Program 15, in conjunction with the EMS. The EMS does not have an accelerometer in the left and right or up and down axes like the IMU and the computer do. So it is just something that you'll have to, unfortunately, deal with. But we are officially 2 minutes to the time that the lock stump starts. Roughly, we're just about 15 seconds away from that 2-minute mark. And once that's in, the minus 2 minutes, we'll get the EMS going, the entry monitoring system. So we're just focused on this knob, this switch, and this box for the time being. So delta V, normal, and that box is now
Apollo
monitoring
7,
the delta V.
everything looks good on the S4B, and you're going
Verb
to the dump.
37, enter.
And also for the
47,
data,
enter.
they plan to dump the DSC over Mila, and we'll have a real fast evaluation on the voyage.
Program 47 here in the computer is going to be what's passively monitoring your burns. You can do them on the SPS, the RCS, you could even do it in the lunar module, or on another system like the booster. So once that burn starts here, we'll see this start to count up. And you'll notice the EMS is a little bit more accurate than the computer is. Computer's got some sort of, it accumulates errors over a large period of time with this program operating, but it's, something we just have to deal with. The cost of not having passive burn monitoring on burns that are, like this one where they're performed by the booster, far outweigh the slight inaccuracies introduced by the monitoring programs. So yep, in delta V on the EMS function here, switch to normal, and this will start counting up at the time of the dump. So about 20 seconds to go here. Twelve, 10, 2, 1. There we go. We can see the entry monitoring system counting down. Interestingly enough, the computer counts up. And that's fairly normal because unlike the computer, where the computer is able to say, okay, we're passively monitoring, so I'll show you how much you displaced in the forward direction. Okay, we thrusted forward, 8 feet per second. The EMS is always
Apollo
sort of
7
in
Houston,
that
we're reading your disk feed.
burn mode
Looks like you're getting
where
some
there's a
Delta V.
target delta V. So it's going to always count down, where it's going to say, oh, you've overburned by 12 feet per second. So because the EMS is as smart as the computer, that's something that needs to be factored. But there's our beautiful lock stump in progress. And she's going to be dumping for about 8 minutes. So we can see computer and the EMS now agree very closely now that the thrust isn't happening super fast. The EMS is a lot more accurate on those small time scales. Its display is updated instantaneously. The computer's display is only updated once per second, so that's why you're able to, at the start, you're able to see, oh, we're at 7 feet per second. The computer still said maybe like 5 feet per second or 4 feet per second. The computer is going to be more accurate with those smaller, fine-tuned delta V's, but in terms of timing for burn cutoff, under manual, it's always done by the EMS. For every time that I've had it occur in Apollo 7 through 12, it's always been the EMS. So it'd be like burn 3 feet per second on the EMS, and then null residuals with the computer, sort of thing. So that's sort of the basics of everything, and I don't think I need to have you guys here sitting and watching this for 8 minutes, so I'll go ahead and pause it, and then when it's done, I'll unpause and I'll show you how to secure this stuff. Super easy, super basic. We're just monitoring delta V measured in feet per second. And you can see 15.3 feet per second. We can see here on the computer 15.0. No decimal here, but they mean, same number of digits here. 15.0, 15.4. And you'll notice this says 15.5. This says 15.1, and that's because actually we're slightly off in our attitude. So you can see why the computer might be, a little bit more accurate, given it has 3 axes measurement, whereas the EMS only has 1. But yeah, I'll pause and I'll resume here when the dump is complete, and I'll show you guys how to secure these things. All right, and that completes the dump. So 30 seconds after the dump, we'll go ahead and secure everything, but that's it. The rest of those vapors will just sublimate away. Pretty cool. 2, 1, mark 30 seconds after. So to secure the computer, we're just going to hit proceed on this program. 0, 0, enter. And that'll write all of that delta V into the state vector. Secure the EMS. You're simply just going to go standby mode and off. And once the computer has written the state vector, program 0 will come up, and you're good. So that's it for the dump. And that'll be it for the monitoring Delta V. Super basic monitoring Delta V. See ya.